let's take a look at G. In G, notice we have a line. That's a little different because it will continue on forever. And notice it does pass the vertical line test, so yes, it is a function. The question is, what's its domain and what's its range? Well, taking it and looking at its domain means to start at negative infinity on the left and work our way towards positive infinity on the right. But I'll say this about our line. Notice that it's got arrows on the ends. What does that mean? It continues on forever. So looking at our line is that it will go forever in the left direction, and it will work its way all the way to the right and go forever in the right direction. So what does that mean about the domain of this graph? It means there's no starting and there's no ending. That means it's going to go forever on the left and forever on the right. So that means our domain is going to have a negative infinity and, comma, a positive infinity, which means it's going to go forever on the left, forever on the right. And remember, it was a rule you should have talked about at some point, is infinities always have parentheses. That's a rule. Whenever you have an infinity, it should have a parentheses. Now let's talk about the domain. The domain is kind of the same idea. We'll start out down at the bottom end at negative infinity and work our way up towards positive infinity. However, notice on this graph is if we start on the bottom, this graph will go down forever on this side. And then working our way up, it does go up forever on this side. So, very similar to the domain, it's going to go down forever towards negative infinity, and it does go up forever towards positive infinity. Which means our range is negative infinity to infinity, and we always use parentheses with both of those. So we're done. So basically the domain and range here, which will be the same for most lines, say that we're going to go forever left and right and up and down. Now I threw in this last one just for fun. Notice, yes, I'm going to call that one H. It is a function, so we'll say yes. It is a function, but I wanted to throw something that was a little bit different so that we could find its domain and its range. And let's see how that goes. So talking about its domain, working from left to right, starting out with negative infinity and working towards positive infinity, what we would notice is that working from left to right is that the graph, let's see, the graph doesn't even start here until we hit 2, but it does continue on forever towards the right after that. So this graph along the x-axis starts at 2 and continues on to the right forever. So what that means for our domain is it's going to start at 2 and then go off forever towards the right, towards infinity. Well, we already know infinities always have parentheses. That's a rule again. We talked about that a second ago. However, at 2, the question is, what are we going to use? Well, we've got a closed circle here. That means we've got a graph that does exist there, which means we're going to use a bracket. We're going to include the 2. That's it. The range is a little bit more difficult, not too bad. We'd start out with working from negative infinity at the bottom, working up to positive infinity at the top. So, starting at the bottom, we'd say, well, notice that starting at negative infinity, our graph does go down forever. But however, working our way up, it does stop here at a positive 3. So working our way from smallest to largest, we're actually starting down at the bottom at negative infinity, and then our graph stops up here at positive 3. The negative infinity will always have a parentheses, just like the positive infinity always has a parentheses. And again, because the closed circle here at 3, we're going to use a bracket here at 3. So this gives you a quick reminder of how to find domain and range, which we will do a lot of this off and on throughout the entire course. So if you're not comfortable, I would spend some time practicing this. The next thing that we're going to look at is function notation. So function notation looks like something like this. We have f of x, and the little parentheses are read as the of. So if you were to read this as a sentence, you've got f, then next is your parentheses, which is of, and then x. So you'd rewrite it as f, your parentheses are the of, and then whatever's inside, in this case, x. That's how it's read. And what it lets you do is ask you, instead of calling everything that comes out a y value, lets us call and ask things a little bit nicer. So now I can call one function f, one g, one h, and I know which one's which, instead of all of them being called y equals and not knowing which one I'm talking about. That can get really confusing. It also lets me do something like this, is to say something like find f of 2, which means to go to your function that's called f, it's like a name, and then whatever's inside should be an x value. Here in this case it would be 2, is go plug in an x of 2. So wherever there's an x, plug in a 2. Just gives you a quick way to kind of ask different questions now. So let's take a look at this first example. In this first example, we've got f of x equals 4x plus 3. And they want us to find a bunch of things here. They want us to start off by finding f of negative 2, which means to plug in a negative 2 wherever there's an x. And remember, just like before, whenever you plug anything in, put parentheses around it. So we'll leave the 4, and then the x is going to get replaced with this negative 2. Don't forget your parentheses. Then we've got our plus 3, those outside. Now, order of operations is going to make us do the multiplication first, the 4 times negative 2, which is negative 8. Then we can add the 3 at the end, which will give us a negative 5. And what this means is when you plug in negative 2 for x, you get out negative 5 as your y value. So it's actually a point you can plot. X is negative 2 and y is negative 5. You can plot that point. Let's take a look at B. In B, they want us to find f of 1. So just like the last one, it means we're going to plug in a 1 wherever there's an x into our function f. So that means our function f was 4. Then the x will get replaced with a 1. Just like the last one, don't forget your parentheses when you plug in anything. And then we have the plus 3. Remember, order of operations is going to make us do the multiplication first. So 4 times 1 is 4. And then we've got our plus 3, which is going to give us 7. So what that means is when we plugged in a x of 1, we got out a 7 for our y value. So that's a point you could plot, 1, 7. Next one looks a little funny. They want us to find f of a. Don't treat it any different. What it means is to take this, whatever's inside, this case an a, and plug it in wherever there was an x. So we've got 4, and then we replace that x with an a. And then we have our plus 3. However, notice you cannot add the 4a and the 3 just like you couldn't add the 4x and the 3 because they're not like terms. So we're done. So if we find f of a, it just means to take an a and plug it in wherever there's an x. Next one, f of b. plus 2 means to take our function and wherever there's an x, plug in this horrible thing, the b plus 2. So we'd start out with our 4 again, and we'd replace the x with a b plus 2. The key is that's pretty complicated looking. We need to be careful not to forget our parentheses when we plug something in. And then our plus 3. So there's some math we can do on this one. On this one, we can actually distribute the 4 to everything on the inside, which will get us, let's see, 4b plus 8. And then we've got our plus 3. There is one more thing I can do. I can combine like terms. I've got an 8. Let's see. I've got an 8 and a 3 I can add. Those are like terms, so let's go ahead and add those. So I've got a 4, so I've got, let's see, a 4b plus 11, because it's a positive 11. However, this is not an equation, so you can't go any further than this. You can't combine or add the 4b and 11. There's no equation to solve, so we are just done. So the key here was not forgetting the what? The parentheses. If you had forgotten the parentheses, you would not have known to distribute that 4. In this next function, we've got just a bunch of points. But they're still calling it the function f, and they're telling us to find f of 2. Well, remember, whatever's inside of those parentheses is an x value. So they want me to go find the point from this function that has an x value of 2. Well, there's only one point that has an x value of 2, and that is the third point here. It has an x of 2. So we have the x. That must mean that we're trying to find the outcome, the y value. Well, the y value would be the negative 5. So when I plug in x of 2, I get out a y value of negative 5. On the last one here, they say find x, which means I don't have x, which means I must have y. And so we've got we want to have f of x equal to 2. So again, we're trying to find the x that will give us this, which means that this y value is already a 2. So let's go find the point for this function that has a y value of 2. Well, the only part of this function that has a y value of 2 is the last point. It has a y value of 2, and that means it's got an x value of 1. So what x gives us this is an x value of 1. And that's our final answer.